Hello doctor, my name is Nazreen bin NORHISHAM. My matrix number is DE20801. So right now I'm going to present about lab 2 for power system. So for the first question, which is the exercise 1, the instruction is a 500 kilovolt 3 transpose line is composed of one ACSR 1,272,000 CMI 45/7 beaten conductor per phase with horizontal conductor configuration as shown in figure 1. The conductors have a diameter of 1.345 inch and a GMR of 0.5328 inch. And then we have to find the inductance and capacitance per phase per kilometer of line and justify the result using MATLAB. So as you can see here in figure 1, we have a distance from A to B, which is 35 inch, and then distance from B to C, which is 35 inch also, and then the distance from A to C is 70 inch. So we have to find the value of inductance and capacitance per phase kilometer by using MATLAB. So this is the MATLAB code for the exercise 1. So we just have to write the code in the MATLAB, and then after that we can run the simulation. Then after we run the simulation, we enter the value of distance for A to B, which is 35, then press enter, and then distance from B to C also 35, and then distance from C to A is 70. And then enter the value of GMRL, which is 0.0444. Then after that, we enter the value diameter in inch, which is for conductor 1.345. So here, this is the value for C for our capacitance, it is 0.0083, and then our inductance L, which is 1.3802. And then we proceed to exercise 2. So in exercise 2, we also have to find the inductance and capacitance per phase per kilometer of the line and justify the result using the MATLAB. So now we have the conductance diameter, which is 0.977 inch, and then we have a new parameter, which is bundle spacing is 18 inch, and then we simply write the code in the MATLAB, and then this is our code. So after that, we try run the simulation, and then we enter the value of AB, which is 35 inch, and then BC 35, CA 70, and then the diameter of conductor in inch, which is 0.977, and then bundle spacing inch is 18, and then the GMR is 0.3924. Then we press the enter. So this is our value for capacitance, which is 0.0107, and value for inductance L is 1.0588.
Assalamualaikum and good evening to Doctor. My name is ISMA KHAIRIN bin MOHAMAD MD, and I am from Group 4. Today I will explain about Power System 2, which is Lab Power System 2, which is online computation of the line parameters. So I will explain about exercise 3A. This is exercise 3A, which is 355 kV double circuit 3-phase transpose line is composed of two ACSR 1431 million 45 stroke 7 berboling conductor per pace with vertical conductor configuration as shown in figure 3. Conductors have a diameter of 1.427 inch and a GMR of 0.564 in the bundle, spacing in 18 inch. Find the inductance and capacitance per pace per kilometer of the line and justify the result using MATLAB. So this is a figure for exercise 3, and it also has been given the program to do in MATLAB, which is program 3. This is the program. And I have copy paste the program in the MATLAB, and we need to change a little bit of the program like this. For the example is this one, the A1 B1 ABS A1 minus B1. We just create this one and we just click enter because I have run it before. Okay, for the first in common window, for the first output, we need to enter the row of vector, which is S11, S11, S22 and S33, which is we just key in the input. For the first one is 11, 16.5 and 12.5. Alright, and then enter row vector H12 and H23, which is the value that we key in is 7 and 6.5. Bundle spacing in inch. The question is given is 18 inch, and the conductor diameter in inch is 1.427, and then the geometric mean radius in inch is 0.564, and then this is the output, which is GMD is 12.0323, GMRL is 1.0312, GMRC is 1.0937, L is 0.4914, and capacitance C is became a 0.0232, and this is the work space of the exercise 3. Okay, for the discussion in this project, we can compare the performance of the power system and the computation of line parameters, design power system equipment, and develop control algorithm. The transmission line is determined by the parameters of line, which is R, L, and C, are the parameters necessary for the development of the power transmission line model. System analysis is performed both during the planning and operation stage, while the position of the conductor is best determined by manufactured data, inductance, and resistance. Capacitance can be calculated using a suitable formula. The inductance is calculated using the flux linkage per ampere. If the conductors are not spaced equilaterally on the three phase lines, the inductance of each phase is not the same. Unbalanced circuit result from difference inductance in each phase. Conductors are transposed to balance the inductance of the phase, and the average inductance per phase is calculated using simple formulas that vary depending on the conductor configuration. The experiment goal is to determine the positive sequence line parameters, which is L and C per phase per kilometer, of a single phase and three-phase single and double circuit transmission line for different conductor arrangements. as well as to understand medium line modeling and performance. One of the most important components of an electric power is the power transmission line. Its primary function is to transport electric energy from power source to load with minimal losses. That's all from me. Thank you.
Hello, Assalamualaikum, and good day to viewers. My name is Muhammad FARIS, CE190084, and now I'm gonna to present about discussion regarding our lab, lab 2 of power system 2, which we are from Good Pro, and as we can as we can tell you that we already come to a discussion that we can distinguish the performance of the power system and the computation of between the line parameters, design power system equipment used, and development control algorithms, which we already all implemented in the MATLAB simulation. And the transmission line is determined by the parameters of the line, and the RLC are the parameters necessary for the development of the power transmission of the line model. The system analysis is performed both during the planning and operation stages, while the opposition of the conductor is best determined by manufacturer data, inductance, and resistance, which capacitance can be calculated using a suitable formula, which we can determine it by the formula theoretically, of course, and the inductance is calculated using the flux linkage per ampere. If the conductors are not spaced equilaterally on the three phase lines, the inductance of each phase is not the same at all, and the unbalanced circuit results from different inductance in each phase. The conductors are transposed to balance the inductance of the phases, and the average inductance per phase is calculated using simple formulas that vary depending on the conductor configuration. And to wrap things up, so we already come to a conclusion that the simulation was carried out for single phase and three phase in various configurations, which is the number of conductors in each example is altered from range 1 to 2, and the results were compared and distinguished, of course. For both single phase and three phase lines, the inductance decreases and the capacitance increases as the number of conductors increases, as proven in the results written. So the inductance value is large for three phase line when compared to single phase line, whereas the capacitance value is small for three phase line when compared to single phase line for the same value of conductors. So that's all from us. Thank you very much for watching.